Have you ever wondered, what is zirconia? You may associate it with imitation diamonds, or maybe you've heard about its use in dentistry, but those are not the only things it's good for. In this video, you will see its many different uses, from ceramic tiles to applications in the nuclear sector. You will also find out how a tiny piece of it might be the oldest thing in the world, and how NASA is using this material on Mars as we speak. Zirconia, also known as zirconium dioxide, is a combination of two elements from the periodic table, zirconium and oxygen. Together they form a white crystalline oxide of zirconium. Let's take a look at the different forms zirconium typically takes. Zirconium is a transition metal with the atomic number 40. It can be found in the same group as the well-known metal titanium and the lesser-known hafnium. It's so similar to hafnium, in fact, that it's a challenge to separate the two metals, which are frequently found together. Zirconia, also known as zirconium dioxide, seen here in its mineral form badelite, is an oxide of zirconium, which means it has one or more oxygen atoms attached to it, 2 in the case of zirconium dioxide. This is the mineral from which imitation diamonds are made, in the form of cubic zirconia. Cubic here refers to the crystal structure of the mineral. It can also be found with other crystal structures, which we'll talk about later in the video. The chemical name for zirconia is ZrO2. Zircon, also known as zirconium silicate, is similar to zirconia, but where zirconia has zirconium and oxygen atoms in its crystal lattice, zircon has zirconium, silicon, and oxygen. The chemical name for zircon is ZrSiO4, meaning it has one zirconium atom, one silicon atom, and 4 oxygen atoms. There are many other zirconium compounds with different uses, but for the purpose of this video, we will just look at the basic metal and its more common crystal forms and their uses. Zirconium metal has a silvery grey appearance, and it's harder than steel. It's a non-native metal, meaning it's not found in nature. It's predominantly found as zirconium silicate or zircon, and is relatively abundant in the Earth's crust at about 165 parts per million. This makes it the 18th most common element, behind carbon. Extraction of zirconium from the Earth is mostly achieved by mining ancient mineral sand deposits where it's found as zircon crystals. Other than zircon, titanium minerals are also mined from these sands. Most of the mining takes place in Australia and the African continent, with almost half of the roughly 1.5 million tons of zircon mined annually being consumed by China. Considering that a developing nation like China is using so much of it, it begs the question, what are they using it for? Clearly, they're not just using it for jewellery or dental implants. In fact, once mined, zircon sand has a great many uses. It can be micronized and used as an opacifier in ceramic glazes and tiles. This gives them a bright white appearance. It can be turned into zircon flour by milling it into a fine powder. This powder can then be used in a variety of applications, some of which include ceramic coatings for foundry molds, ceramic shells for investment casting, and refractories, materials used to build vessels or structures such as kilns and furnaces that need to withstand immense heat. Zirconia can do this because it has a tremendous ability to withstand heat and retain its stability. These applications are of particular interest to a developing nation like China, as raw materials produced in this manner are in high demand. The flour can also be used in abrasive products such as sandpaper, or it can be melted down and ground into ceramic frits for use in glazing. It can even be used as insulating fibers and as an additive in glass production. Some of the most well-known uses for zircon sands are things like dental implants and gemstones that give diamonds a run for their money. You might wonder how sand could end up looking like a diamond, or a tooth for that matter. The path from zircon sand to cubic zirconia isn't actually very complicated. It looks like this. The sand is mixed with coke, a type of carbon fuel, and heated to its fusion point in excess of 2800 degrees Celsius, or over 5000 degrees Fahrenheit, in an electric arc furnace, where it decomposes. As zirconium dioxide is heated, it undergoes two important changes in its crystal structure. At room temperature, it is in what's known as a monoclinic structure. This is just a way to refer to the arrangement of the atoms within the crystal. When heated above 1170 degrees Celsius, the crystal structure begins to change to a tetragonal form. This is the structure that is most often used for dental implants and crowns. Once heated past 2370 degrees Celsius, the transformation to a cubic structure takes place. This is the form that's needed for gemstones, and the reason for the name cubic zirconia. If the zirconia is allowed to cool, however, it will revert back to its former monoclinic structure. To stabilize it in one of these forms, the zirconium dioxide can be mixed with stabilizers such as yttrium, calcium, or magnesium, depending on the manufacturer's process and customer's needs. By varying the amount of stabilizers used, the zirconium dioxide, once cooled, can remain in its tetragonal state for applications in dentistry, and in the cubic state for use as a gemstone. This form also increases the toughness and hardness of the crystal, in addition to improving the appearance. The cubic arrangement of the crystal is the same as that of a diamond, which also helps to give it that sparkle associated with a diamond. Although if viewed side by side, the two gems are fairly easily distinguished from one another, even to the untrained eye. Could you guess which one is which? Stick around to the end to see if you were right. Zirconia has been used in dentistry since the year 2000, when computer-aided drawing and manufacturing technologies enabled the manufacture of crowns and implants from ceramics like zirconia. Prior to this, implants were typically made from titanium or other ceramic materials, or metals like cobalt-chromium alloy. It's interesting to note that humans have actually been creating dental implants as far back as 500 BC. Egyptians even fashioned tooth stabilizers from gold wire in 2500 BC. Remains from the ancient Etruscan civilization show that people used oxen bones as teeth replacements, and the Mayans even used shells. Transplanting teeth was actually a thing back in the 1700s. Typically, poor people would elect to donate their teeth to rich people for a small payment. Sometimes, teeth would even be taken from dead bodies. In today's civilized world, though, titanium is still a popular option, given that it is well studied and known to stand the test of time. The same cannot be said for zirconia implants. Although they are aesthetically superior and have a number of other benefits, there is less long-term data available for them, and the data that is available shows that they're more prone to failure from cracking and chipping. It's definitely not a clear-cut decision, and the pros and cons of each material need to be considered when choosing a dental implant. Some of the zircon sand we saw earlier also ends up somewhere you might not expect, in nuclear reactors. This is because of its unique ability to absorb very few neutrons from the fission reaction, relative to other materials, and it's extremely stable under the high temperatures in the reactor. Incidentally, the metal, hafnium, which is so hard to separate from zirconium, is actually used as a control rod material, which means it absorbs neutrons, slowing down the reaction so that the operators can control it. Now, I said at the beginning of the video that zircon may be one of the oldest things on Earth. And it's true, the oldest object we have ever found that is of Earth origin is a grain of zircon crystal. We know this because zircon has yet another trick up its sleeve. It's great at holding onto uranium but ejecting lead during its formation. Knowing this, we can analyze the ratio of lead to uranium, and knowing the decay rates, we can calculate with great precision how old a particular crystal is. This crystal was found in the Jack Hills of Narrier Gneiss Terrain of Western Australia and has been measured at 4.404 billion years old. Give or take 8 million years, that's less than 0.2% error margin. This crystal has been kicking about on planet Earth basically since there's been a planet Earth. The crystals are incredibly durable, which is why they stick around for such a long time. Zircon crystals have even been discovered in a Martian meteorite, and it's helping scientists to gain insights about the composition of the Martian interior, something that was previously not possible. Speaking of Mars, NASA are already using this multi-purpose mineral right now on Mars. On the Mars Oxygen In Situ Resource Utilization Experiment, better known as Moxie, as a solid electrolyte in the form of a thin sheet of yttria-stabilized zirconia, positioned between two porous electrodes. Without getting too technical, it allows CO2 to be collected and split apart into carbon monoxide and oxygen. Basically, it acts like a tree, breathing in carbon dioxide and exhaling oxygen. This is a crucial experiment as far as the future of manned missions to Mars are concerned. Humans will need a lot of oxygen to survive on the red planet, both for breathing and for use as a rocket propellant. If we want to send humans back home from Mars, then they will need approximately 45 metric tons of oxygen fuel. Currently, Moxie is about the size of a car battery and can produce about 10 grams of oxygen per hour. That's 0.022 pounds. Future versions of this technology will need to be 100 times larger in order to support the astronauts that go there. So now that you've made it this far, it's time to reveal which one of these gems is actually a cubic zirconia. If you guessed this one, you were right. Cubic zirconia gives off more of a colourful sparkle known as its fire, whereas diamonds have a unique quality called scintillation, seeming to switch between black and then bright white. It creates a striking contrast in the sparkle, which is hard to miss when you have seen it once. It's truly amazing to see the huge variety of uses that stem from one simple metal, from gemstones to nuclear fuel rods, from dental implants to our future fresh air on Mars. I hope that you found this as interesting as I did while making it. If so, hit the like button. If not, there's a dislike button too. Of course, any comments are welcome, and if you're curious and want to read more about zirconia and its uses, then the Zirconia Association is a nice starting point, and I'll put the link in the description. If you'd like to hear more from What Is Everything in the future, feel free to hit the subscribe button, and I'll see you next time.